Newton's method. You'll see it on, I was going to have a picture of this and everything else, and so on. So he started off with some basic function, right? You know, y equals some quadratic, okay, or second degree polynomials. And then he said, okay, well, if I want to just find where the approximation of the square root of 5, or the square root of some constant? Oh, that's an extra credit question if you want. You do that one, I'll leave that there. I'll put that extra stuff on the, so it's like a little homework for extra credit for the midterm, yeah? So that's like 5 points easy, okay? All right, that's another thing that they beat me up with, all right? So he said to himself, well, there's a method of actually how to approximate. And the first thing was, remember we talked about it yesterday, was that x1? They gave you x1 or whatever it was, or you had to, usually you had to just, they gave it to you. But here, we had to approximate. So what he did is he knew his perfect squares, right, and Rabson as well. And he said, well, the square root of, because they didn't give him x1. Well, the square root of 5 is between the square root of 4 and the square root of 9, which is around 2 and 3. So then he said to himself, well, which one is it really closer to? So he said, I bet you it's really 2. So the first value that he said, that x1, is right there, 2. Now the next thing is he actually said to himself, there's a formula that he helped develop, and that's right here. It looks pretty familiar, doesn't it? That x of n, and then x of n plus 1. He said you take the function, okay, x of n plus 1, and then set it equal to the first guy, the beginning value, and then subtract the quotient, you know, of the function divided by the derivative of that function. Pretty easy. Yeah? So the first thing he said was, well, I know the first value that we said was 2, right? So then it's 2 plus, and then you put 2 inside the function, which is 2 squared minus 5 up here, right? And then what's the derivative of x squared minus 5?
2x.
Yeah. See, right away, you boom. I had Julie here and Abby Biggs. They were doing the square root of 17 or something. They just like, there was nothing to it. So you get a certain value here, right? So you plug this in, you get 1.75, right? And then you take the 1.75 and then you do the same thing. You keep on iterating. You keep seeing it. Plugging it in, plugging it in, plugging it in, plugging it in. And then roughly, like they say on Cambridge, you do what? Well, approximate to 2 decimal points.
Yeah.
Well, you go 175, 273, 230, 23 something. And then they had another value, which I haven't done yet. And this comes out to roughly 2.24. And if you look on, hold on, if you look on your calculator or do it on your calculator, it'll be approximately around 2.24. Nick first.
So, but like when you got the 2.24, do they all have? Does there have to be at least 2 that can come to that round of that same spot?
Yeah, okay, so you're going to get 2, right? And then 2.3026. Then it does this, 2.24, right? 3.7. And then it keeps going on. It keeps, you keep getting repeated stuff here. And then you round. Yes, Ryan.
Okay, so in the problem that they would give you,
yes,
what would be given?
Okay, this one would be given right here. We're going to do one on Cambridge. It's very similar. I'm just showing you what they're doing, what Newton did in the 1700s.
What's the thing under it?
Under it,
F
here?
No, F prime, it says?
F prime of x. I just said prime of x.
There's the equation, the 5x. What is that?
That's the derivative of the first. That's the first.
2x?
Yeah, it's supposed to be 2x.
Okay.
Thank you.
That was confusing me.
Yes.
Also, the square root of 5. What's that from?
Yeah, what do we...
Was that a given?
Yeah, well, yeah, they wanted to know what the square root of 5 was, because if you solve this out, if you solve this for x, wouldn't it be the square root of 5?
Yeah.
Oh,
Okay, that's the
that's
function
what
that they gave you.
Okay, so they just
Yeah.
gave you a function.
Yeah, they gave you
You
function, yeah,
solve-
which is a here. See it? X squared minus a. And then it starts converging, that sandwich thing. It starts getting to that 2.24.
How do we know when to stop doing this?
It keeps repeating. And then on the test, okay, or on the midterm or whatever it is, I like 4 or 5, max. And you're going to see it, and I'll say go to 2 or go to 3.
Never mind.
No, never mind. Okay.
So you mean, like,
It keeps
go for
doing
X2,
this.
X3, X4.
Yeah.
You want us to go to X5 or X4?
X5 would be sufficient. You're going to see it's going to repeat there. Ryan.
So the square root of 5 is the thing that satisfies x.
Yes.
in this equation. So
Yes.
theoretically, they could just give you the equation and not give you the square root of 5 and just ask you to find what satisfies the x. And then
They could say something like this. Approximate what the square root of 17 is.
Okay.
And then you go, oh, well, f of x is equal to x squared minus 17.
Okay, because
Okay, so
Then f prime of x is 2x.
Because
And
the
then
one
you
that we
just-
did right here.
Yes, I know, I gotta do that, yes.
Satisfy the X. So.
Yes, I'm gonna do that as well, okay? Don't worry. I just wanted to show you the method that was 200 years ago before Cambridge adulterated it. Yes?
I was going to say, there was a formula we used yesterday.
Yes.
The thing we did yesterday, what
Yes.
was that? That's where we,
Yeah, how you satisfy? Yes.
the X, and then we just plugged it into the equation.
Yes, yes.
Instead of.
I will,
that
right.
weird thing. What's
This
the
is
difference
Newton. This is Newton. I'm showing you the application. What's going on. And now I'm gonna get into Cambridge.
between- The difference between when you use those two formulas?
You would be given, I mean, it would say Newton's approximation, right? That's it. I'm just showing the application. Before Cambridge came around, there was Newton. And Newton knew a lot more than a whole battery of Cambridge AICE, okay? They did, all right? Then I did the same thing for the cube root of 10. Same process. Right? Because then all I had to do is, I approximated. See, I said x cubed, I should have wrote x cubed minus 10 equals f of x. And then here it is, x cubed minus 10. And then you take the derivative of x cubed and the minus 10. The minus 10 goes away, right? So then it's 3x squared, the first derivative. And then I plug that thing right back in there. Yes, Brian?
Okay, so when you have the cube root of 10,
Yes, sir.
how do you know to do the 8 and, oh, you just pick.
I picked one.
The next two.
Yeah, you could have picked one here. Let's say Sophia said, I think it's close to 3. And she's going to put 3 in here, and it's going to start getting a lot less than 3. And she's going to go, oh, okay. Right? It'll keep decreasing from 3. And if I pick 2, it's just a little more than 2. Right? And if you look at the number here, isn't 10 closer to 8
Yeah.
in the radicand than 27? You see it?
Okay, so you pick the next, if it's a cube, you pick the
The
lower
most
and
perfect.
higher perfect cube.
Correct.
If it's a square,
Yeah.
you pick
Yeah. That's it. That's all I wanted to
two
talk about.
perfect squares that's
Yes.
between.
Yes.
Yeah, that's
How
what
about the
we did.
5th root, the 19th root, or whatever?
Yeah.
Right?
X to the 5th minus 10.
Yeah. Yes.
Yesterday, they gave us a
The cosine
margin.
thing? Yeah.
They said between 1.3 and 1.5.
Yes.
So those were our, yeah. Okay.
Yes, they gave you the values, right?
Uh-huh.
All right, now I'm going to show you what Cambridge did, okay? But Newton, I I played with this forever, but I'm half as old as Newton. Or some people think that I'm even older. Pardon me?
Is this the logic that calculators use?
Well, this is, you can argue, this is a classic algorithm that helped develop numerical methods or analysis, which you call calculus. This is what it does. Guys, this is just no different. X squared minus 5, right? 1, 2, 3, 4, 5. So you guys are going to do something like this, right? I don't care about that side, right? It has an intercept and all that other jazz, right? No big deal. Well, what they're doing is Newton is doing all these approximations. There's x of 1, and then he's doing another tangent, x of 2, and finding the difference between there. X of 3, x of 4, x of 5, and he's doing those approximations. He's doing the slope. Yes, ma'am?
So after you get all those numbers, how did you get a 2.24?
It'll converge. It keeps going to 2.23. It's going to go 2.238, and then it does another one. See? It's like, oh, okay. It's 237, 238, then it goes 2.239 for the next one. You see what I mean? You see it converging, sandwiching?
Yeah, but where do you get the 2.24? Is it eventually coming
It's
out?
because I rounded. I rounded.
See,
I looked at the most obvious thing that I see, and then I round. We're going to do it. Yes, go ahead.
Well, the thing is that that's just going to keep
Keep
going. It's never going to stop.
No, it's irrational. Right.
It's one of those.
It's going to go.
Yes,
like,
yes, that's right.
If
It
you
is.
kept
It's one
going
of those.
on like infinitely,
Yes.
it would go 2.2399999.
Yeah, it'll keep doing
But
it.
eventually, as you do it, the change in the numbers is so small,
Insignificant.
that
So you can
you
just assume that
pick-
it's.
Right. And to show you, he did this one right here, okay? It's hard to see. Here, so you can get a picture. Whoop. See where it says convergent example? Got it. Got it.
Yes.
He's got it. Now look at all the decimals. Pass it around just the square root of 2. They started off with the square root of 2 right here, 1. Then they got, well, you could do 0, but it's right. But they just said 1, right? And then they said, because the square root of, because it's pretty close. Look at all the convergence that is happening there. They did it to 60 digits. So they knew that the square root of 2 is roughly 1.414.
So since what we're doing is basically just approximating
Yes.
the square root, so
Yes.
if you plug it in,
Or function, or function.
you get that.
Yes,
So
or
then
function.
I plugged in square root of 5, 2.236.
Yeah, 2.236. Well, look at 2.237, 2.238, and so
There we
on.
go.
So, I mean, it's not going to be perfect. It's an approximation.
That's how you double check yourself, though.
That's true. Well, that's what I use in my head sometimes to do square roots or cube roots or
Can't
n
we
roots.
just,
Yes.
because
Why can't you just hit the calculator? I know, yeah. But this is just Newton's method. That was just an application. Okay? That's all it was. When you take calculus 1, if you do take calculus 1 or calculus 2, you're going to get some person that stands up there, maybe me again, oh no, and he or she is going to say, they're going to say, well, we're going to do approximation of Newton's method. Boom. They do it.
I mean, if I go to UCF and you work there,
Well, if they ever hire me, you know.
I'll get you.
Commute's going to kill me. Can I ride with you? Okay.
You can stay. You can.
Oh, really?
You can stay in my place.
Oh, thanks.
You'll
Thanks.
As long as you pay half the
You'll
rent.
pay
Oh.
80% of the rent.
Yeah, all right.
80%.
I think we're going to pass. Okay, yeah.
I just
Yes, sir.
You should ride with me. We'll get there sooner.
He's French faster. All right, no big deal. And I just did a cube root. This is just an explanation. All right? Now let's do one that's on Cambridge. Better? Okay. That's all it was. Now I'm going to try this one right here, which is, I believe, ladies and gentlemen.
You discovered a way to make calculators useless. You just want.
Well, this just takes longer, right? Your calculator has some algorithm that does it.
Oh,
Let's try. Did I do May, June 2010?
Yes.
I did it. I started it. I finished it.
Yes.
There's
I did
one
with-
in May, June 2010 though, you gotta say which one.
Okay. Oh, I'm sorry.
This one
32.
yesterday.
Or
We did this one yesterday.
Nope.
Did I do this one?
No. You said to try it though.
Okay. All right. Well, let's try it together.
Okay.
How'd you do? Did you do okay?
I did like for the first part. I wasn't quite sure what to do, but
Okay. All right.
yeah.
So here we go. I'm going to just try to write it around here because I got another class. Okay. So we'll do one or two together, and then we'll call. I think that'll probably be plenty. So I think you guys will really catch on to this. All right. How to do it? What are they going to ask? And of course, I'm going to do the stuff for the midterm, one or two of them. Okay. But all right. So this is number 4. Okay. Whatever the number. Okay. And then you're given y is equal to sine x over x. Okay. And what do they want, ladies and gentlemen?
May, June 2010, number 4.
Yeah. They want you to prove that it's true or something,
They
right?
want you to prove that M satisfies the
Yeah. So you got something like this. Is it a sine curve or cosine?
sine wave.
So sine goes like this, right? And then
Or wait, no, that's cosine.
it says
it's cosine.
The circle of 1.
y equals sine x.
All right. So here, let's just do this one,
Just
okay?
the curve.
So the first thing that you do, okay? They want you to prove it. Okay. Let's call this the prove thing. Prove one.
Wouldn't be.
Yeah, I know. I'm already doing the bottom. I'm sorry.
There's a reason why
So,
we
yeah,
have in
yeah.
literature.
Oh, yeah. So the first thing you're going to do is take the derivative, all right? In this one. So, well, let's u high, low, right? So y prime is going to be u high, low, right?
Loading high minus high below all of
Is that okay? I write it this way. u v prime minus v u prime over v squared is equal to dy du over v dv, okay?
Yes.
All right? Not bad? Yeah, sure. So, there's a minus sign there. You take that bottom one and you square the bottom. Okay, now, what's over here? Well,
X cosine of x.
x cosine of x. The man's correct. So far, so good? X cosine of x.
Sine x.
Sine.
Well, the derivative, remember, I didn't do anything to the first, and I took, it doesn't matter the order how you do it, right? Well, I just did it.
Wait.
This is my
Not
u,
that. Yeah.
that's my v. So,
Just sine x.
you, because what's the derivative of sine? It's cosine.
Yeah.
Yeah.
And then the second one.
Oh, you already had to be,
cosine,
sorry.
yeah.
I'm sorry.
It's just sine x. Because,
Times 1.
Yeah.
Okay? Okay so far?
Yes.
Pretty easy. Now, you set this puppy equal to 0.
Yes.
Yep. Nick, am I doing it right? He'll tell me.
And then you can multiply both sides by x squared to get rid of it.
That's correct. So I know that if I multiply that by x squared, it's gone, right?
Why are we setting the derivative to 0?
Because I want to find out and make that thing look like tangent, right? I have to make the...
And now we have to do the.
Oh, we want it to look like that.
Yeah, you want to make it look the same. So this is the proof, or let's call it the mirror.
Cosine, and then it's tangent equals.
Yeah, you already had it. Remember the song from Michael Jackson, Am I in the Man in the Mirror? Okay, right? So they give you something, does the reflection look exactly like the same thing? So we're doing that, okay? So he's right, multiply by x squared, okay?
Which we've done. We've done this.
Okay, x squared here. So then I know, so you're already ahead of me, right? X cosine x minus sine x equals 0. So far, so good?
Well,
Yeah? Okay, now what? Put one to
sine
the other
over
side.
And then divide.
Yeah, x, right? Now I'm going to add sine, and I'll do the steps. Not a bad one to do. And then divide by cosine of x. Here's my tangent of x. x equals sine x over cosine of x. And you guys had me like 2 years ago, and all of you know your identities and your reciprocal properties. Yeah, whatever, Murmer. So then you get x equals tan of x.
Yep.
Yep.
Stop right there. Okay? Not bad?
Whatever you plug in tangent, you get it.
Yeah, well, right, exactly. Now, this is like the 4-step method, but you don't need to know that. Because it screams to me how to do limits in x of x plus h minus x of h over. Okay.
So,
I don't get out of that. All right?
for things like
All right.
those,
Yeah?
we don't have to do the other thing. Like
What other thing?
That's the next step.
That's the next stuff, okay? Whatever.
Get it to look like
Okay? I had to make it look like what they had there, okay?
Remember the trig identity ones where we had to get this, first step was get
One
this to look
side
like
on,
this
the
big,
left-hand side equal to the
and then you
right-hand
do
side.
something with it.
And then you had to do this whole spluff. Yes,
And
sir.
if you didn't
So-
know how to get from point A to point B,
You
you
could
could
just
just
go to
start
the
with point
second-
B.
Second part and trust that it.
Yeah, if I always say look for, there's so many ways to do them, but yeah.
Remember
Everybody
this?
okay so far? I can get really into this, but, because I love teaching trick. All right, can I erase this portion?
Yes.
Yeah.
All right, Eileen says move it. All right, I'm moving.
Remind me of that thing.
All right, next victim, right? So the next one is double I.
Yes.
Okay, and it says to do x of n plus 1, yeah.
Are you gonna find that that math problem is a victim?
Is it do something like this?
We're the victims.
Does it give you this?
Yeah.
Okay, it gave you this, right?
Yeah.
Sir.
Yes, sir.
What is that derived from?
It just, it's from the previous example, right?
Yeah, so they just.
Yeah, they just give this to you, right?
Okay.
Okay,
And-
so that's just
Yeah, they just give it to you. That, like Newton's like, tell me the square root of 34, okay? And so he or she just gives this to you. And then they say they give you a value, right? X equals x1. No, I hope not. Equals 4, all right? All right? x1 equals 4. So now all I have to do now is to do what? Plug in 4. And I believe it has to be in radians, right?
Where's the 4 from? Yeah.
Yeah, where'd you get
Did they give
the?
you the 4?
No.
No, they said correct 4 decimal places.
Yeah.
They give you 4? Okay, hold on, let me look. I thought they gave you a 4. Oh, yeah.
We need to figure out what M is, I think.
Given the result of each 4 decimal places, why didn't they give you 4?
This iterative formula could be used to determine the x coordinate of M. Use this
Why did
formula
they
to
give you 4?
determine the x coordinate
Yeah,
of M
what's-
correct to
what's
2
that?
decimal
Oh,
places.
I got
it's between
0.785.
pi and 2 pi.
It's good. There we go. Because it's between pi and 2 pi. Right?
Yeah, they're right there. You have to look in the graph because it has pi.
Yeah. I won't be this mean. I'll tell you the value, okay? On the test, I will tell you the value. X1 sip, Sophia. Okay, thanks. All right? All right? What I have to do is buy a coffee, all right? Okay, so everybody okay how they got 4?
Yeah.
What?
I'm going to give you the value on the midterm.
They got 4?
Yes, how'd they get it? They
Oh,
looked at the
because it's
graph.
pi and 2 pi, okay.
Pi and 2 pi, right?
So in between 3.14 and 2.68. Or
But
that's
wait.
2.28.
They got it from the graph, and they probably just calculated
What's
it.
4?
All right, hold on, Bella.
M.
Bella. I couldn't hear you.
So what do you use to find it? Like how do you get 4 out of each of the
We
time?
did this
Yeah.
yesterday.
Use 5, 2, 4, 6.
Wait. What's 4? The answer or
No, the first value. The
No,
first
it's-
value is 4.
is it
What does this
0?
even tell you?
But it doesn't tell us that.
It doesn't, sadly, it doesn't tell you.
So how do we find that?
All right, hold on.
Mr. Murmer?
Okay, choose a value, here it is, between pi and 2 pi.
So we just have to
Any
choose
value.
Where does it say that though?
That's what I said, okay? Because I looked at the graph, all right. You wanted to know exactly, because you guys are smart, like, hey, don't make up stuff. Because the interval's between pi and 2
So
pi.
we know it's between there somewhere.
It's somewhere in there. Guys, remember we did the one that's 1.3 and 1.5?
Yeah.
Okay, well that's like saying this.
Didn't we just plug in?
So
Yes.
you just pick something that's in
Pick something in between there,
Oh,
I think they picked the whole number closest to the lowest bound.
probably.
Well, it was the lowest
Because
bound.
3.14 and 6.28, right?
Yeah.
Okay?
okay. But when we did it, didn't we just pick the 1.3?
Yeah, we took the low guy.
Yeah,
So he
now
took,
we're not taking the
they
low.
took the one that's in between here, right?
So could you just pick the low
You
one?
could pick the low one, it doesn't matter.
Okay.
Can we just pick 4 for fun?
Yeah.
Is that okay?
Yes.
So that's where it comes from,
Better
oh,
than
okay?
pi.
All right.
I'd
So
rather
you're,
not have
so
it
if they ever
come
give this to you, you want to know how, right? So if they give you a picture, that's it. If they say X1 is 5, you rock and roll with 5. All right? Yeah.
I did something completely different, but I got the same
You
answer.
will get the same answer. Okay?
So what I did
Right.
was, like, remember the sine of x over x?
Yeah.
I took the derivative, set it to 0, solved for x, and then
Yeah.
I took that x value and used that.
Yes, you
to go
can.
with.
Yes, you can. Yes, you can. Okay, yeah. Clever, as usual. Okay, so we're okay with 4?
Yep.
We're all right with 4. You could have gone 3.4 or 6.28, right?
Sure.
All right. So all I have to do now is x of 2 is equal to tangent minus 1 of x of 1, which is 4, plus the pi guy. Anybody want to tell me what you got?
So
And hopefully I
wait,
have the
are we
right.
doing this in
Same.
this or radians?
Put it in radians.
Okay.
Okay, that's always a big thing. They love radians a long time. Okay, they love radians.
4.467.
Correct.
4674.
4.4674.
Yeah.
All right. Does everybody need help on how to do the radian deal?
Wait, how do you switch it? Don't you just
It should be just one button that you push. Grad degrees rads.
Oh, okay.
Yeah.
Just make me thirsty. Okay. All right. So you just plug that in. Okay. Hopefully there's no rum in there. Okay. I just thought of that.
So now we're talking about.
Now you take this one. What's this guy now? This is not. This is now.
4.674. So now we're trying to find x of 3.
X of 3
Using x of
equals
2.
tangent minus 1 of, not 4, 4.4674, whatever,
Plus pi.
plus the pi guy, and you get what?
Give me 2 seconds.
I'm sorry. I worked.
3.14 or use pi?
Use
4.4921 or 22.
4.
You have pi on your calculator?
Yeah, I think so, but I just.
Remember, pi in radians is 314, right?
Yeah.
Okay, so you're going to get 1 and change here, right? You just subtract 3.14, and that's really the
I
value.
just used the pi.
Yeah, that's okay. Caitlin, okay? Ms. Ripper? She's okay. All right. Next guy. Now this guy is x3. x3 equals, x4 tan 4 point, was it 49?
Yeah.
22?
We use the
Yeah.
value that we got.
4.22.
You keep iterating that value. Boom, boom, circle. It's a loop.
4.4933.
4.4934.
I'm gonna go out on a limb and say 4.49.
Now they wanted. Now you see it there, Sophia.
Yeah,
Not bad.
4.49.
It's starting to repeat. Two
Let's just do
decimal
one more
places.
time.
If you want it one more time, right?
Then we go out and back here.
Minus 1 here. Minus 1. 4.4934 plus pi. What'd you get?
4.4934. Again.
It repeated. Oh, woo woo.
We found it.
So it's going to be 4.49. Game over. Thank you. Give me my points. I'm on to college to Murmer. Okay?
Give me the $64,000.
Go ahead, Ems.
I just had like
It popped. Yeah.
because like I thought we were averaging it.
No. Well, you know what?
Now
You
I
can.
get like.
Yeah, you're looking for what repeats, right?
Yeah.
It's recursive, so to speak. It keeps going on. 4.49, 4.49. It's a robot. It keeps saying it over and over again. It must be converging to it.
Yeah.
Just like it did here. Newton did this 340 years ago. Do you know he was born on the same day that Galileo died?
Hey, he was reincarnated.
Yeah.
Galileo was reincarnated.
Okay?
He picked up where
This
he left
one's a
off.
King Kong. This one's not. Okay. The only thing that's King Kong on it was doing the low, high, high, low. Okay? Your derivative of the quotient of a derivative. Yes? Okay? Is this okay?
Yeah.
It makes sense.
Makes sense?
The page says one with an E.
Which one?
E to the negative x.
I won't lie to you. All right?
That's exciting.
I'd like you to star number 6
Which one?
The LN.
on May, June 2010. Yes, ma'am.
33.
Yeah, are we?
No,
Okay.
because there's not enough time.
Yeah.
I was thinking, well, you know what? Just to torture him, just give him the sample, right? And then hand all those questions in with everything else? No. The cat went, no, and I couldn't do it.
How do you do
It's the first one. It should be the first one. Oh, well, hold on. All right.
So wait, what?
Okay, I think I have my sneaker. What's up? So, notes here, right? And I believe it's this one. Yeah, there it is. Yeah, okay. Okay, any questions? Not bad?
So we're doing May, June 2010, number 6 with ln of x over x.
Ooh, I like that one.
How do you do that?
That
Would
one.
you like to try? How do you do it? Okay.
Yeah, let's do that one.
Is something like that going to be on the list?
One of them. Okay? Could be anything, right? And I'm going to give, tomorrow you're going to like, I don't know what's on the midterm. Then you're like, oh, that's on the midterm. Okay? You'll know exactly what's on there. Okay? I've done that for over 100 years. You know, like, I don't believe in surprises. But I do believe on a little pile-on because we went over a lot of stuff. But you will be okay if you go over that stuff. Or you work with someone, or you bug me at Suckbucks or something, or you like, I don't know how to do this. Like, all right, well, if the person took that much time and it's 9 o'clock at night, I guess I should answer, right? Okay? That type of deal. Now, math, I won't lie, it's arrogant to say this as well. It's like erudites, if you believe in divergent, right? It's the queen of all sciences. Okay? This is it. You're the top. You're here. Depends if you want to stay here. It's like medical school, right? They don't choose anybody that doesn't belong in a medical school, but they choose people that whether or not they want to stay in medical school.
Can we do number 5?
Number 5.
Well,
Which,
yeah, number 5 and number 6.
you want to do 5?
Yeah.
Yeah, number
All right,
5 and number
5.
6, because we haven't worked with an E or an L on yet.
E,
And we'll
okay.
figure out how to do it.
All right, okay. Everybody okay with this one? But 6, we might not have enough time. How much time we got?
We got time.
We have 10 minutes.
10 minutes. All right, so
Exactly 10 minutes fast.
don't freak out, because I'm going to go over trapezium tomorrow, which isn't bad, but it's the way to integrate things,
It
okay?
looks like half the page is taken up by that one.
It's an alternate way to integrate?
Yeah,
Oh.
yeah.
Oh, here he's-
All right, so 5, right? And this one, I forgot the number. What, 2010, whatever?
Yeah, May
33.
2010, number 5.
Okay, you know it's number 5. Okay, what's it want?
Funny.
What's it want, everybody?
Find the exact value of P.
Okay, P, whatever P. So it gives you, this is the original function, right? E of negative x minus E of negative 2x.
Yep.
Okay. You know right away you're going to do something to this thing.
P is, ooh. Okay.
Integrate.
Not integrate. Other one.
Derivatives.
Right. Because the inflection points are based upon her saddle points. You'll learn that later. And Mrs. K would say the same thing. Her head fall off all the verbiage that I use, okay, from nodding, okay? If it's an inflection point and everything else, or it's first or second derivative. For you guys, it's the first derivative.
What is an inflection point?
Inflection point is in the graph. You know, e to the x, I think, does something like this. Whoop, okay, and it has something right here. Inflection point is where it bows or it does something of this magnitude, right? It has a minimum and a maximum point.
That's the inflection.
That is the inflex of the graph from increasing to decreasing functions.
That's where it changes direction.
Yes, okay? It's
We've talked about it.
yeah, it's getting on the freeway.
Okay.
Whoop, and then you go somewhere on the other portion. It's a good question.
That's where it
Don't
changes
worry,
direction.
you'll be writing me later saying, "Oh, I know what that means now," or
Okay,
even better. Okay.
so
here we go.
What they're saying is that the maximum point M
Yep, is when
is denoted by P, and P has a 0 for Y.
so far so good. That better?
Uh-huh.
Okay.
He's not here.
She's like, my graduate student is on this. Okay. All right. So now we got to take the derivative
It's
of
an
this
easy
thing.
graph.
Remember, derivative of e to the x is just
E to the x.
e to the x.
Then you
You take the derivative of the
Or
exponent.
dx, right?
Yeah.
It's dx, that's right.
E to the x dx.
Whatever that is. Okay.
Actually, it's e to the u du because it's not just plain x, right?
Right. So this one, is this a positive? Okay. So this one's a minus. So notice there's a -1 there, right?
Uh-huh.
So this one's going to be, here we go.
E to the x.
This -1 comes down. Yeah.
So it's negative e to the negative x.
negative x
So far so good.
Plus E.
Plus
plus
Yeah. Now it's going to be
Yeah.
+2. You see it?
Plus
See it?
P
Plus 2
e
e to
The
the
negative 2x.
negative 2x.
Woo.
All right.
That's the thing.
That's the thing, like a chicken wing. Okay.
What?
Yes.
Everybody okay?
Yeah.
Just it's your power. I call it the power rule. To me, it's because it's n to the x on -1. It's the same thing for e. You're just doing stuff with the exponent and multiply with the sign. All right.
Wait, it says show that the area of the shaded region.
I gotta get there.
That's next.
I gotta get there. I gotta find what p is first,
Oh wait, we have a
and I gotta find what the upper lower bounds are, right, for the integration.
Uh-huh.
Man, impatient.
Slow down.
P is the same thing as
All right,
X.
so I want to solve for P here, right? Or solve for, for P. Because this thing is really equal to P, all right? So the next thing is I set this equal to what?
0.
Because
Equals-
y is 0 for p.
That's correct.
Yes.
Plus 2e to the negative 2x. Now, what do you think's next? Ooh. Get 1 to the other side, right?
Well, we have to do that Ellen thing.
There you go, you're thinking, as usual. So, I'm going to bring this one, it doesn't matter, right? Doesn't matter. So, I'm going to, for some reason, I like that positive, I'm going to bring that guy over. Is that okay?
Yep.
So, I should get, writing it here, 2e to the negative 2x equals e to the negative x. Because whatever,
Yeah.
okay? It'll come out that way.
You're missing a negative.
I'm missing a negative?
No.
E,
No.
for the
No.
other one, the E thing.
Yeah, oh, here it is, it's right here. Thank you, Kemi. I put it there, but you're right, and I'm missing a negative there, that's what you meant. Thank you.
So how do you ln that?
All right, hold on.
There's a 2 in front of it.
Well, I gotta get these guys on top of one another, or something like that, right?
Oh.
Oh, snafu!
Nothing's clicking, there's just a.
I know. I know.
You
Divide by the base, right?
Uh-huh.
It's all about the base, no trouble. Yes? Error.
Did it matter which one that
No,
you divided by?
no, sir. I perform magic and then the seance. Then I talk to my grandfather, okay? Yes. So what we do here is we use the law of exponents, right? And that says if the bases is the same, keep the bases while subtracting the exponents. Minus 2x, see what I did? Just showing the steps.
So it would be.
2 equals e to the negative x plus 2x. So far, so good? I got 2 pesos. Mrs. Ripper takes 1 peso. How many pesos do I have left? E to the x.
2 is e to the x.
The now
ln.
ln. The natural log of both sides, right? Because it's an e. You guys didn't have me last year because I had a book and I kept on showing e through the thing.
Because we're trying to get this.
Yeah, you're trying. What's the exponent, right?
Okay.
And so you take the natural log. Is it okay if I just, because I'm lazy, on both sides? So far, so good. Sophia, okay? So that means it's going to be here. The ln of 2 is equal. Now this thing drops, right? Drop it
Yeah.
like it's hot, and it's going to be x ln of e, which ln of e is just 1. It cancels out.
Yeah.
So it's just going to be x.
So x is ln of 2.
ln of 2, and everybody knows that the ln of 2 is negative 0.6931. Am I right on that one?
Yes.
Indubitably.
How do you?
It's going in my head.
Okay.
It's like
Simple
I'm already up to the
numerization
40th
is always gonna be
digit.
that.
Sorry.
Always going to be that.
It's actually for half-lives. Okay.
Yeah.
All right. You want this killer one?
What's the other?
ln of 2 is negative.
6934.
It has to be negative. Yeah, it's half-life
Why is it negative?
because it's less than e, which is 2.71.
But the calculator's
Murmer,
positive.
you mean like
No, it's-
radioactive decay happens?
Yes. 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 You could go to